Hello everybody, welcome back to Beginning Algebra. Today we're in section 1.4 and we're going to be talking about adding real numbers. Now what this really means for us is learning our rules for adding positives and negatives. All the numbers you're going to see in this course are real numbers, but when a math book says they're going to show you how to do operations with real numbers, what that really means for you is that the rules you're about to learn work for whole numbers, for integers, for decimals, and for fractions. So today I'm going to show you how to add two numbers with the same sign, how to add two numbers with different signs, and we'll talk about the rules for order of operations when you're adding real numbers, and we'll also practice translating words and phrases that indicate addition. So here we go. Now first off, the answer to an addition problem is called a sum. And the two numbers that are being added together are called add-ins. We don't need that word very often, but every now and then we might want to use that word. So the answer to the addition problem is a sum, and the numbers that are being added together are called add-ins. So for example, if we have x plus y equals z, then the add-ins are the x and the y, and z would be the sum. Now, there are only two rules for adding signed numbers. Now, remember, right now we're only talking about adding, and there are only two rules for adding signed numbers. The numbers are either both the same sign or they're not the same sign. So if the two numbers have the same sign, then what you'll do is you'll add them and keep their sign. If two numbers have different signs, though, what you'll do is you'll find their difference and keep the sign of the larger number. So to get started with this, let's think about a bank account. So we're going to work with an imaginary bank account, and whenever we make a deposit in this imaginary account, that's going to be like adding a positive number, and whenever we make a withdrawal, that's going to be like adding a negative number. So you might think, well, a withdrawal would be like a subtraction, and you're exactly right, but just for this section, instead of saying subtract, let's say adding a negative number. Now, let's suppose we start with a $100 balance and we make a $20 deposit. So you know in the real world, if you have $100 and you make a $20 deposit, you're going to end up with $120 in your account. Okay, now let's take that $120 and let's make a $50 withdrawal. So that's going to be like saying 120 plus negative 50. So you know that if you make a $50 withdrawal, that's going to leave you with $70. Okay, let's take our $70 and let's say we write a check for $80. In other words, we make an $80 withdrawal. Now, pretending for a minute that they would actually let us do that, if you have $70 and you make an $80 withdrawal, then you are $10 in the hole, right? So you've got now negative $10. Okay, now suppose that with that negative $10 balance, you make another $40 withdrawal. So that would be negative 10 plus negative 40. If you're overdrawn $10 and you make another $40 withdrawal, now you're $50 overdrawn, so that's going to be like negative 50. Let's take that negative $50 balance and make a $20 deposit. Now that will help, but it won't get you out of the hole. So negative 50 plus 20 is only going to get you to negative 30. You're still $30 in the hole. And then if you take that negative 30 and you add a $100 deposit to that, now you're $70 to the good. So really, even though you might not have thought you knew the rules for adding positive and negative numbers, you really do know the rules quite well. So let's look at what happened here. If you add two positive numbers together, then you really do add them and you keep their sign. A positive plus a positive gave us a positive answer here. And when both of the numbers were negative, we really did add. 10 plus 40 is 50, but we retained the negative sign here. So a negative plus a negative gives you a negative. Okay, so as long as the two numbers have the same sign, we add and we keep their sign. Now, if the two numbers are different signs like they were here, then what you do is you subtract and you keep the sign of the larger number. 120 plus negative 50 is positive 70, because 120 minus 50 is 70, and the larger number was positive, so the answer is positive. Here, 70 plus negative 80 became negative 10, because 80 minus 70 is 10, and the larger number was negative, so the answer is negative. And you'll see that that worked on these last two problems as well. So now that you've worked through some examples of adding positive and negative numbers, you know how it works. So you can go back to this bank example anytime that it's helpful to you, but after a while you'll find that you don't need it, because when you've gotten enough practice with these rules, they'll become second nature to you, and adding positives and negatives will be much easier for you. If this is something that's given you trouble in the past, then right now you might feel a little shaky with it, but it's just a matter of practice. I promise you that if you'll work with these rules and keep using them, then this will get easier for you, but only if you do it yourself and don't reach for a calculator. So I really want to encourage you not to use a calculator on your homework. You need to give your mind a chance to think through these problems. Remember, in beginning algebra, you will not be able to use a calculator on the tests, and you'll never learn the rules correctly if you always lean on the calculator. So always do your homework and quizzes without a calculator. Now we're going to do example 1 together. If you would like to pause the video and try these on your own, I think that would be a great idea, and then we can check them together. And I'm going to go through them now. So let's look at negative 12 plus 5. Now these signs are different, so that means we'll subtract the numbers. 12 minus 5 is 7, and the larger number is negative, so my answer here is going to be negative 7. And then let's go over here to part B, 13 plus negative 8. Now these two numbers are different signs, so we will subtract. 13 minus 8 is 5, and the larger number is positive, so my answer is positive 5. Notice that when a number is positive, we do not have to write its sign. On part C, we have negative 6 plus negative 1. Now these two numbers are the same sign, so we will add them together and keep their sign. 6 plus 1 is 7, and the sign is negative, so our answer is negative 7. On part D, we have 25 plus 8. Both of these numbers are positive, so we will add the numbers and keep the positive sign. 25 plus 8 is 33. On part E, we have 7 plus negative 18. These two numbers are different signs, so we will subtract and keep the sign of the larger number, which is negative. So 18 minus 7 is 11, and we'll keep the negative, so our answer is negative 11. And then negative 5 plus 32, the signs are different, so we will subtract the numbers. 32 minus 5 is 27, and we'll keep the sign of the larger number, which is positive. So this answer will be positive 27. Now remember that these rules work for all real numbers, so not just the positive and negative whole numbers, which are called integers, by the way, but they also work for fractions and decimals. Now we won't see any decimals in this course, but you might see them in later courses. Right now we are going to practice adding fractions with our sign rules. So example 2 says find the sum of each pair of numbers, and here we have a pair of fractions to add together. So now all you have to do is use your fraction rules the same as we always did, but at the same time remember your sign rules. Now remember that adding fractions requires common denominators. So I'll look at the denominators we have here. We have 2/15 plus 3/10. And remember that the least common denominator is the smallest number that both of these numbers can go into. So I know that 15 times 2 is 30, so definitely 15 goes into 30, but also we know that 10 goes into 30. So we can use 30 as our common denominator. I'm going to go ahead and write down two fractions with a denominator of 30. Now what do I have to multiply by 15 to get 30? Well, I need to multiply by 2, so that means I'll also have to multiply the top by 2, and 2 times 2 is going to be 4. And when I look at the 3/10, what do I have to multiply by 10 to get 30? Well, I have to multiply by 3. So that means I'm multiplying top and bottom both by 3. And so the new numerator here is 9. So now we have 4/30 plus 9/30. Both of these numbers are positive. So that means we will add and keep the sign. 4 plus 9 is 13. And the sign is positive, so keep that. And the denominator is 30. And now let's look at part B. Here we have negative 7/8 plus negative 5/6. So both of these are negative. Let's think about finding a common denominator. I know that 8 times 3 is 24, and I know that 6 times 4 is 24. So 24 seems like a good choice for our common denominator. Notice that my fractions were negative, so when I change the denominator, when I write an equivalent fraction, the fraction will still be a negative fraction because it still needs to represent a negative amount. But what do I have to multiply by 8 to get my denominator to be 24? Well, I would need to multiply by 3, so the new top number here would be 21. Now remember, it's negative because my original fraction was negative. And what do I need to multiply by 6 to get 24? Well, I need to multiply by 4. So the new top number here is 20. So now I have negative 21 24ths plus negative 20 24ths. And we know that we're going to add and keep the sign because both of these are negative. So 21 plus 20 is 41. Keep the negative. And we have negative 41 over 24. Now let's continue this example with some mixed number problems. I think that since we have the sign rules thrown in here, it will be easiest for us if we convert these mixed numbers to improper fractions. Remember, that's always an option for us. So I'm going to say that 3 times 1 is 3 and 3 plus 2 is 5. Now, I have seen students before try to treat the 1 as negative, but remember the negative applies to the entire mixed number. So just let the negative sit out front and convert this mixed number to an improper fraction, and then the whole improper fraction will be negative. So again, 3 times 1 is 3, 3 plus 2 is 5. This is going to be 5/6 plus negative 5/3. Okay, now I can think about my denominators. I can see that they're different and they need to be the same. So I notice that 3 goes into 6. That means 6 can be our common denominator. So now the question is, what do I have to multiply by 6 to get 6? Well, I really can just leave it the same. So this top number will stay the same. And what do I have to multiply times 3 to get 6? Well, I have to multiply it by 2. So this new top number will be 10. Okay, now this fraction is negative because the 5/3 was negative. So now I have 5/6 plus negative 10/6. So you can see that the signs are different. This one's positive, this one's negative, and that means I'm going to have to subtract. The difference between 10 and 5 is 5, and the larger number is negative. So my answer is going to be negative 5 over 6. Keep in mind that if our answer had come out improper, I would have converted this back to mixed number form because it was a mixed number problem. Okay, now on part D, we have negative 3/5 plus 1 1/8. So again, I think it's easiest if we convert this to improper form. 8 times 1 is 8, 8 plus 1 is 9. So now we have negative 3/5 plus 9/8. You can see that the denominators are different. We'll need them to be the same. What's a number that 5 and 8 can both go into? The smallest number that they can both go into is 40. So that needs to be our common denominator. So I've written down two fractions with a denominator of 40. This first one is negative because this first fraction is negative. Now what do I have to multiply times 5 to get 40? Well, I have to do 5 times 8. So that means the new top number here is 24. And what do I have to multiply by 8 to get 40? Well, I have to multiply by 5, so that means the new top number here is 45. Okay, now I have negative 24 plus 45. And I know that these are different signs. That means I'm going to have to subtract. The difference between 45 and 24 is 21. 45 minus 24 is 21. The larger number is positive, so the answer is going to be positive, and the denominator is 40. So we end up with 21/40. Okay, now we're ready to move ahead to the next objective, which is using rules for order of operations. Remember, we always have to think about order of operations on all problems that have more than one operation. So PEMDAS is always in effect. Every now and then a student will say to me, do we have to use order of operations here? And the answer is always yes. Order of operations never goes away. Now, when more than one grouping symbol is present, remember we always start with the most inner set. And here's example 3. This says find each sum. And here we have negative 3 plus bracket 4 plus negative 8. So remember, we always do the operations inside the grouping symbol first, and you might be thinking that we need to go to this most inner set of grouping symbols, but all we have here inside this parentheses is negative 8, so there's really nothing to do in there. Those parentheses are just there to remind you that this negative belongs to this 8. So the first thing we want to do is 4 plus negative 8. Now the signs are different here, so we'll subtract and keep the sign of the larger number, which is the negative. So 8 minus 4 is 4, and it needs to be negative 4 because our larger number again is negative. That's going to leave us with negative 3 plus negative 4. Okay, now we just have one addition problem, negative 3 plus negative 4, and so we need to add and keep the sign. 3 plus 4 is 7, and the sign is negative, so negative 7. Okay, now on part B we have 8 plus bracket negative 2 plus 6 plus negative 3. Close the bracket. Okay, so we know we need to work inside the grouping symbol first, but inside our bracket we see another grouping symbol that has an operation to do. So our first operation needs to be negative 2 plus 6. Now the signs are different here, so we'll subtract and keep the sign of the larger number, which is positive. The difference between 6 and 2 is 4, and it's positive. So now we have 8 plus bracket 4 plus negative 3. Notice how my parentheses has now been replaced with just the number 4 because we did that operation. Okay, now still working inside the bracket, we have 4 plus negative 3. The signs are different, so we'll subtract and keep the sign of the larger number, which is positive. And so that's going to give us 8 plus 1, and of course 8 plus 1 is 9. Now let's look at our next objective, which is translating words and phrases that indicate addition. So anytime you see the phrase the sum of, that means addition. Added to, more than, increased by, also just the word plus. All of those phrases represent addition. So for each of these examples, let's write down the numerical expression. First, the sum of negative 3 and 4. So remember, the sum means that we add. So we would write negative 3 plus 4. And of course, the signs are different here, so we subtract and use the sign of the larger number, and we get 1. Then we have 5 added to negative 8. So we would just write 5 plus negative 8. Of course, here the signs are different, so we would subtract and keep the sign of the larger number. That result would be negative 3. And then we have 12 more than negative 5. Now notice it doesn't say 12 is more than negative 5, so we're not talking about greater than or less than symbols here, but it just says 12 more than negative 5. So what this is really saying here is that you started with negative 5, and then you had 12 more than that, so that means you added 12. So let's start with negative 5, and then let's add 12. Again, the signs are different, so we'll subtract and use the sign of the larger number. So that result would be positive 7. And then here we have negative 6 increased by 13. That is simply negative 6 plus 13. The signs are different, so subtract and use the sign of the larger number. And then finally we have 3 plus 14. So you just write it just like it sounds. 3 plus 14, and of course that result is 17. Now let's practice here in example 4. Let's write a numerical expression for each phrase and then simplify. So this says the sum of -8 and 4 and 6. So sum, of course, just means to add. So we'll write -8 plus 4 plus 6. And we'll just work from left to right. -8 plus 4 would be -4. And then -4 plus 6 is simply 2. Because the signs are different, so we subtract and take the sign of the larger number. On part B, we have 3 more than -5 increased by 12. So that would mean we start with -5 and we add 3 more than that. So add 3, and then increased by 12 means we add 12. Okay, now working from left to right, -5 plus 3 will be -2, and then -2 plus 12 will be +10. Now I do want to caution you about one mistake that people make when they're showing their work. I do not want you to show your work like this. So let's say you start with that same problem. A lot of people will write it down the way they're thinking it in their head, and they'll chain their steps together with equal marks. And this is a very bad habit. So this is what I'm talking about. Like with a problem like this, they would say -5 plus 3 equals -2, which is true, but then they'll say their next step is plus 12, so they'll just write plus 12. See, they'll just tack that step on to the end of this previous answer, and then they'll say that equals 10. Okay, well their final answer is right, but I want you to look at this. Right here they have -5 plus 3. We know that that's -2, but this says that it's equal to -2 plus 12. The -2 plus 12 is 10. Do you see how what we have on the left side of the equal mark does not match what we have on the right side of the equal mark? This says basically that -5 plus 3 is equal to 10. That's not true. -5 plus 3 is equal to -2, period. You can't tack on the plus 12. So a good way to show it is like I have it here. Just replace the expression that you're working with its result, but leave the rest of it alone. So -5 plus 3 plus 12 equals -2 plus 12, which equals 10. And so what I have over here would not be a good way to show that work at all. And here we have a word problem. So let's read through this and see if we can write down an expression to help us find the answer. This says a football team gained 3 yards on the first down, they lost 12 yards on the second down, and then gained 13 yards on third down. Write an expression to represent this and find the total net yardage for the plays. Now I think an easy way to look at this would be to say that a gain in yardage is a positive number and a loss in yardage is a negative number. So the first thing they did was they gained 3 yards, so we'll put down +3. And then the next thing they did was they lost 12 yards, so that would be plus -12. And then on third down they gained 13 yards, so that would be plus 13. Okay, now let's just work this from left to right. 3 plus -12 will add up to -9, and then -9 plus 13 will add up to +4. Here's one you can practice on if you would like to pause the video and try this one on your own, but now I'm going to go through it with you. This one says, on 3 consecutive passes, a quarterback passed for a gain of 6 yards, was sacked for a loss of 12 yards, and passed for a gain of 43 yards. And we want to write an expression to represent this and then find the total net yardage. So again, it's a good idea to let a gain be a positive and let a loss be a negative. So a gain of 6 yards would be +6. A loss of 12 yards would be plus -12, and a gain of 43 yards would be plus 43. Now, working from left to right, the first thing we want to do is 6 plus -12. Here the signs are different, so we will subtract the numbers and take the sign of the larger one, which is negative. That's going to give us -6 plus 43. And then again, the signs are different, so we'll want to subtract and use the sign of the larger number. That's going to give us positive 37. So if you were shaky on your rules for adding signed numbers before, I hope you feel a little bit better about it now. Keep practicing, keep thinking about it, and remember, hands off those calculators. Do not use a calculator when you're working on your homework or your quizzes, because you will not have one available to you when you take your proctored test.